Good morning, boys and girls. It's Miss Fontilius in my kitchen. So we're going to do math today in my kitchen. And I can't go backwards and fix anything I record. So I plan on making lots of mistakes. And I'm hoping that you're going to be just like, oh my goodness, Miss Fontilius, you tried so hard at something A, you're good at, but B, you're very new at doing recordings. Okay, so what you need, first of all, is go get your math stuff, alrighty? Go get your supplies. Let me show you what we're gonna be doing today. So I've got it on our little objectives here, and I bet you can't see that. Okay, I'm gonna have to figure out how to do that. There's my refrigerator, and there's my bowl of oranges. Okay, there we go. Okay, so let's learn math. All right, we're in week 4 of our remote learning. Woo woo. Okay, so this is day 1 of 4, and we're going to try lesson 19. We're going to give it a whirl, all right, guys? And that is to explore how to use inverse operations to solve equations. So here's what you need. And I'm going to pause the video so you can go and get things, and I think you can pause it as you want too, so you can be ready. Get your writing tools. You know you like your paper and your math binder, so you know your vocabulary. And number 2, get your ready math instruction book, because we're going to be working on page 190 and 191 today. And then don't forget your problem solving book, because you can do some practice on these concepts. So that'll be page 203 and 204. So get all that ready, and I am going to pause for a moment. Well, hi, boys and girls, you're back. So you should be on page 190 right now of your lovely math book. Let's see if I can, uh-oh, now I just messed something up here. There we go. Page 190, 191. That's what our lesson is going to be about. And we are going to explore how to use inverse operations to solve equations. Now, if you look at that picture there on that page, on this page 190, you can see we've done a lot with pan balances. So you should be really pretty good at this. We just got to get our brain back into the swing of things. And I've got to figure out how to do this so that we can learn and move through the lesson. And you know, it's so silly because in a way our whole point of our math was always think, share, compare. So we're going to be doing a lot of thinking. If you know, and I'm going to start thinking about how we can share through Google Forms, but one thing at a time. And then we'll compare with some of the answers that I have with me in my book. Okay, so first of all, I have my notebook. Do you have your notebook? Do you have your notebook? I have my notebook. All right. And I wrote lesson 19, and today's date is, let's see, Tuesday, April. Wow, it's already the 14th. Can you believe it? Hey, we're gonna make it. We're gonna be okay. All right. So first of all, something that you need to remember what inverse means. And if you have, and I have my little handy dandy whiteboard there. If you have your math binder, you can look and pause this and remind yourself what inverse means, or you can just wait it out and decide, inverse means opposite. Inverse means back and forth. Let's see. So the inverse of addition is subtraction. The inverse of subtraction is addition. What's the inverse of multiplication? Division. And what's the inverse of division? Multiplication. Is multiplication and addition an inverse process? No. And division and subtraction? No. Okay, so let's go to this page right here where it says use what you know, lesson equations. It's an introduction. So check this out. You've seen that an equation is a statement that states two expressions are equivalent. We've been doing that for so long. In lesson 18, where we left off, and you did quite well, you learned that what it means to solve an equation. Take a look at this problem. Okay, so we're going to take a look at this problem, and then I'd like you to pause, or I might be pausing for a moment because I want to get my paper down and I want to see if I can kind of figure out what means. And remember, to read a problem, you should have it about 3 times. So the picture below shows a balance holding 10 blocks and a bag with an unknown number of blocks. The balance beam is horizontal. How many blocks are in the bag? Again, the picture below shows a balance holding 10 blocks and a bag with an unknown number of blocks. Okay, 10 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. What? I see 8. Oh, okay, 10. All right, 10 total. The balance beam is horizontal. How many blocks are in the bag? So you might be really good at this based on how much you've been doing on the boom cards on solving these equations. So it says, use the math you know to start to answer the question. So I would like you guys on your book, in your instruction book, and write down the answers. And I'll give it a few seconds for you to think. And then if you want to pause before I say anything, go for it. So here it is. Write an expression for the number of blocks on the pan on the left. And of course, if we could be doing this together, you guys would be reading these things to each other. And A, write an expression for the number of blocks on the pan on the left. Okay, A. I would say it's x plus 2. Wouldn't you guys? Because if I recall, an expression has a variable, an operation, numbers, but no equal signs. So let's see. So A, I have x plus 2. B, what will you need to get the bag by itself on the left side? Ha ha! So if you want to get the bag by itself on the left side, you need to do what? You need to subtract 2 from the left side, don't you? Let's see. You will need, okay, let's see. What will you need to do to get the bag by itself on the left side? Well, that seems so obvious. You need to subtract 2 blocks. Let me go. Take 2 blocks. Take 2 blocks from the left side. Well, that seems obvious. And C, then what must you also do to keep the balance beam horizontal? Oh, well, of course. C, so let's see. B, let's see, what we must you do to be able to hold the balance. What will you need to do to get the bag by itself on the left side? Okay, B is take away 2 blocks. C, then what must you do to keep the balance beam horizontal? Well, don't you also need to take away 2 from the right side? So C, take away 2 from the right side. D, explain how you could find the number of blocks in the bag. Pause for a second. You guys, I want you to think about that and explain that in D. Oh. Oops. Okay, now I'm back to recording. Maybe I have been the whole time. Okay, you guys. All righty, let's do this. Okay, so sorry if I just made you watch me sit there and think. Well, basically, D, explain how you could find the number of blocks in the bag. Well, if you take 2 away from the left side and you take 2 away from the right side, all that's left up here, so that means X must equal, if I take away 2 from here, And 2 from here, I get 1, 2, 3, 4, 5, 6. So D must mean X equals 6. All right, we know that. Ready? Moving on, page 191. All righty, exciting time here. I wish I would like to just free to pause for a moment and read that section to yourself so that when I read it to you, you'll go, okay, all right, pause. All right, here I am. Okay. No, find out more. To find the number of bags in the blocks, you had to do 2 things. First, get the bag with the unknown number of blocks by itself on one side of the balance. True. And you did this by taking away 2 blocks from that pan. Okay. Second, to keep the balance beam horizontal, you did this by also taking away 2 blocks from the other pan. The balance blocks and bag represents the equation x plus 2 equals 8. Oh, yes, it was true because, there was 8 blocks on the other side. But here's the deal. And now I want you to look down at that whole process there that's showing you how to do this, and listen up. Get the variable. First, you get the variable by itself on one side of the equal sign. And this, guys and gals, is so crucial because that is called isolating the variable. And if you isolate the variable, you get it all by itself. And when you do that, you have to do the inverse operation. So, second, keep the 2 expressions equivalent to each other. Another way to say this is you need to keep the equation balanced. So how do you isolate the variable in the equation x plus 2 equals 8? Notice you're using addition. So you're going to have to subtract to get rid of it. So use inverse operations. Inverse operations are operations that undo each other. Addition and subtraction are inverse operations. Since the expression x plus 2, since x plus 2 has 2 but being added to x, you can isolate the x, or meaning get it by itself, by subtracting 2. So if you go x plus 2 minus 2, you get rid of it. Now take a look down here at the bottom. How do you keep the equation balanced after isolating x? Subtract 2 from the other side of the equation. So now this is I don't know, I hope you can see my cursor here. So x plus 2 equals 8. So x plus 2 minus 2, you want to get rid of it, right? So to get rid of it, you want to undo it by subtracting 2. But what you do to one side of the equation, you have to do to the other to balance. So 8 minus 2. So now you've got x plus 2 minus 2 equals 8 minus 2. And boys and girls, it's really important not to skip these steps. When you get into more advanced algebra solving equations, your teachers will want you to show all the steps, because I'm guessing in your head, you did all of these steps right in your head. And you realize that x plus 0 equals 6, or x equals 6. Now, number 1, reflect. Write an equation for which subtracting 5 from an expression would isolate the variable. So I want you to think about that. Write an equation for which subtracting 5 from an expression would isolate the variable. Write an equation for which subtracting 5 from an expression would isolate the variable. Okay, I think yours could be anything, but I wrote x plus 5 equals 12. Write an equation for which subtracting 5 from an expression would isolate the variable. So I had to use addition. Did you use addition? X plus whatever equals whatever. Because if you used addition, you have to use subtraction to isolate that variable. So I would go x plus 5 minus 5 equals 12 minus 5. I've just isolated that variable. So it means this undoes itself. So I'm left with x equals, and what's 12 minus 5? 7. Did you do the same kind of thing? All you had to do was do some kind of addition, because if you want to use subtraction to get rid of it, to isolate it. All righty, woohoo! I'm going to stop for a moment and pause and kind of talk about the last part of this lesson. You did great. Okay, kids, thank you. I tried my best. You know, it's not that exciting. I have to tell you before we leave for today's lesson, my little gnome has had a very rough weekend. Look what happened to his hat. Oh, man. So let's talk about your home learning, which everything is home learning, but let's talk about how to practice this concept so that you can move on to the, the next one. And so that would be I tore this is out of your problem solving book, page 203 and 204. And you'll notice there's about, about 8 problems or so, 8 or 9 problems. And if you want to keep your brain in check, and as you solve them, I'm not quite sure how, we can turn them in yet, or how we can talk about the problems, but I'm thinking about that yet. So notice this is a prerequisite, so something you really need to know before you get going. But I just want to talk about this example and look at the vocabulary. Equation, a statement showing that 2 expressions are equivalent. Alrighty, so just remember that. Kanika divides a package of sunflower seeds equally among 4 flower beds. So I see the S stands for seeds, and here are the 4 flower beds. She plants 14 seeds in each bed. Write and solve an equation to find out how many seeds were in the package. You can draw a bar model to help you write and solve an equation that represents the problem, because the equation is the seeds divided by 4 beds is going to give you 14. That represents the problem. But the equation is asking what number divided by 4 equals 14. You can solve a division equation by using multiplication. So since 14 times 4 equals 56, or 56 divided by 4 equals 14. Therefore, there are 56 seeds in the package. So here comes your questions. What does S represent in the example? What does the expression S divided by 4 represent? Don't forget to really write out your problems, guys, and really write in mathematical thinking, because you know the expectation, that's not something that is going to change just because we're at home. Alrighty, I want you to keep your brain going. I'd like you to practice page 203 and 204 and enjoy yourself. And I'll have tomorrow's lesson for day 2 of 4. Shoo. Have a good day. Love you so much. Thanks for being patient with me. And I'll see you in our Zoom meeting.